Hello, this video is going to introduce you to the graph of logarithms. So in the first example, we're given an exponential equation y equals 2 to the x. We put that equation in our calculator, go to the table, and create a list of coordinates for us to plot. And we get the graph on the right-hand side. Now what we're going to do is we're going to graph the inverse of y equals 2 to the x. And remember that anytime you see the word inverse, this means to switch your x and y values. In other words, I'm going to take my table and I'm going to switch the values here. So why don't you pause the video, take a minute, and fill out the rest of the table for the inverse. So now I have my table completed for the inverse of y equals to the x. I'm going to take all my coordinates and I'm going to plot them on the graph. I'm going to take all of my coordinates and I'm going to draw a line through them. So in my table, all I did was switch the x and y values, and graphically what I did was reflect over the line y equals x. So that's two different ways to know that they're inverses. And this is going to be f inverse x. Don't actually know what to call it yet. So basically, I started with a exponential equation, and the new equation, the inverse, is what we called a log equation. So log functions and exponential functions are inverses of each other. And by the way, log is short for logarithm. Now, actually coming up with the equation, I have y equals log of x. Now, this isn't quite it, but you see how we have a base of 2 here? Well, logarithms have bases as well. So I'm going to take my base from my exponential and I'm going to make it the base of my log. And because it is the base, you have to write it below everything else. So exponentials and logs should always have the same base. Now, please be careful of how you write it. If you write it like log 2x, that is not correct because this is a big 2. These two equations are not the same thing. So the size is important here. And the way we're going to say it is log base 2 of x. Now, looking at the graph, the exponential equation has an asymptote, right? There's no shift going on here. So it's a plus 0. And that means your asymptote is going to be y equals 0. It's going to be the x-axis. Now, keep in mind the inverse, when you switch your x and y value, my asymptote switches as well. So instead of having a y equals 0, my asymptote of the logarithm is going to be x equals 0. Instead of a horizontal line, the inverse is going to have a vertical line. So it is important that on your graph for the logarithm that you didn't touch the y-axis, just like how we couldn't touch the x-axis for exponential functions. So this is y equals 0. This is x equals 0. Now, let's actually recall how to find the inverse of a function. There are 3 ways, and I just mentioned 2 of them in this video so far. So the first way that we did it was by taking the coordinate and switching the x and y value in the coordinate from the table. If you want to find the inverse graphically, you're going to reflect over the line y equals x, the diagonal line in the graph above. And then algebraically, we would switch the x and y values in the equation and solve for y. We're going to learn how to do that later on. For now, we're just going to work on the graphs. So let's recap with what we knew about exponential functions, right? We had exponential growth. You also have exponential decay, but I'm going to stick with growth for now. And our domain for exponential functions were all real numbers from negative infinity to positive infinity. Your basic exponential function has a range of 0 to infinity, right? Because you can go up forever, but you can't go downwards because of your horizontal asymptote at y equals 0. If you don't have any shifts going on, your quadrants that exponential functions are going to be in is quadrant 1 and 2. Your x-intercept, well, there is none, because we never crossed the x-axis to have an x-intercept because of the asymptote. Your y-intercept, however, is going to be 0, 1, provided we don't have any transformations going on. Now, logarithms are a bit different. Remember, we're dealing with the inverse here, so we're going to be dealing with everything being switched. So guys, you remember your domain is your x values and your range is your y values. So if we're talking about inverses, it makes sense that our domain and range switches as well because we're talking about x and y values switching. So if the domain for exponential was from negative infinity to positive infinity, those were my x values. For logarithms, that's now going to turn into my y values. And my range is going to be from negative infinity to positive infinity now. I can go up and I can go down. However, with exponentials, my range was limited. I only had positive y values. With logarithms, my domain is going to be limited. And I'm only going to have positive x values from 0 to infinity. We're flip-flopping. If originally I had an asymptote of y equals 0, if I switch my x and y values, now my asymptote is going to become x equals 0. And that's why it's important we know which one is which, because a lot of times the Regents questions try to trick you. The quadrants that we're going to take up are the two on the right-hand side. That's quadrant 1 and 4. Now, before we had no x-intercept, but we're switching the x and y for the inverses, so now I'm going to have no y-intercept. Because of that asymptote at x equals 0, I can't touch the y-axis. Now, my y-intercept for exponentials was 0, 1. My x-intercept for logarithms is going to be 1, 0. Provided, again, that there's no shift going on. So try your best to remember just the basics for the parent functions of exponentials and logarithm equations, because there's a lot of Regents questions that ask you about them, and they will try to trip you up, specifically with the asymptotes and also your intercepts. And you definitely should know the shape of both. Exponentials, we are heading on up, or if it's decay, we are heading on down. On the Regents, usually every time we see a logarithm, it's going to look like this. So we should be able to tell whether it's a logarithm or an exponential equation based on the picture immediately. And that's all for the video.